and global minima also, which we call it as absolute maxima or absolute minima. It is also called absolute maxima, absolute minima. So for example, you have a graph maybe like this. From here to here, this is the end point B. This is the starting point A. So you come across many maxima, local maxima, like this is a local maxima. This is also a local maxima. So similarly, you get local minima also. This is a local minima here. This is a local minima here. But what is absolute? Absolute is the maximum of all the values. So this you can see is the maximum of all the values. So this is the absolute maxima. Similarly, if you see minimum of all the values, then this is the minimum of all the values, so absolute minimum. So when you want to find absolute maxima or absolute minima in an interval a comma b, closed interval, so what you do, you find by f dash x is equal to 0 or undefined all the critical points as we used to do earlier. So we get x is equal to C1, C2, Cn. These are the critical points. As you can see here, this is C1, this is C2, this is C3, this is C4. This there the derivative is 0. And you find the value at A, at C1, at C2, similarly at Cn, and at B, at endpoints also. So you have to, one second. So you have to find all the values at the endpoints. This is endpoint from starting. This is endpoint from end. And all the critical points. These are the values at the critical points. And you see among all of them, which is maximum. That will be called absolute maxima, which is maximum among all of them. Similarly, there is an absolute minima, which is minimum among all of them. So we also see the endpoints. Now here there is a difference. Have you written this, Darnell?
Yes, sir.
Okay. Now if it is for the open interval a comma b, that is endpoints are not included, and suppose the graph is something like this. So this is a, the value here is not included. From after a we are including it, and here it is b. So what we do, we find all the critical points here also, C1, C2, C3. Curve is little absurd. It should be smooth. So C3, all the critical points. And also you're finding at C1, you're finding at C2, if you're finding at C3. And also you find the value at x, where limit x approaching a plus, because a you cannot take, but a plus you can take, right of a. Similarly, limit x approaching b minus fx, left of b. So these are the endpoints, right of a and left of b. So if you see among all of them, you are getting a local maxima. If local among all of them, it is important to understand here, among all of them, if maximum is among FC, FC1, FC2, FC3, then it is absolute maximum. Here it is very conceptual thing which I am going to tell you. And if maximum is from limit x approaching a plus fx or limit x approaching b minus fx, then we say then absolute maxima does not exist. So what is important thing here is just try to understand. As I have shown the graph here, you see all the values. You see the values at f of c1, you see the value at f of c2, f of c3, and right of a and left of b. Among them, if c1 output, c2 output, or c3 output is the maximum of all the five, then that will be the absolute maximum. But here, as you can see in this graph, that limit x approaching a plus fx is actually maximum. This is maximum, as this is less than that. 1 second, a call is coming. Okay. So as you can see here, it is the a plus output, which is maximum. So here we will say that absolute maxima does not exist, because if you say that the output is limit x approaching a plus fx, its value L, so that value L is not included as it is an open interval. So that means absolute maxima does not exist. Similarly, if you talk about the absolute minima, you see the output at all the C1, C2, C3. If C4 is there, then C4, C5, all the endpoints, and at B. And here you see among all the minima, this C3 is the minimum. Now this is not the endpoint. So here absolute minima exists. So here also we have the statement for minima, same statement, that if minimum is among FC1, FC2, FC3, then it is absolute minimum. So here in open interval, you have to see such things. If minimum is from limit x approaching a plus fx or limit x approaching b minus fx, then again we will say then absolute minima does not exist, because that value is not in the interval. So here in above graph, what you will say above graph, absolute maxima does not exist because it is at the end point and end point is not included. But absolute minima exists, and it is, as you can see from the graph, the minimum value is f of C3. It is f of C3. Have you understood it, Darnell? Hello?
Yes, sir.
Okay. So do you want to write this? Have you written?
Yes, sir.
Okay. So in closed interval, it is not an issue. In closed interval, we take all the critical points and the end points, and we see which is maximum and which is minimum. That is taken as the maximum or minimum. But in open interval, we if we get a maximum or minimum at the end point, then it does not exist. Otherwise, at critical points, it exists. But we see that at end point, what is the value? We don't ignore it. Now, if you questions on absolute maxima and minima. Let me see. Do you have NCRT with you right now?
Yes, sir.
Okay. So just try question number 5, third question from the exercise 6.5, and question number 11. Just try these two questions first. Then one more question on trigonometry also, because they have given many such questions on trigonometry. So at least one should be done. Question number 9 also you try. Three questions. We'll discuss them. So steps are clear now how you have to approach. Hello.
Yes, sir.
If you will have any doubt anywhere, you can ask me, Darnell. Okay.
No, yes, sir. Oh, so I'm not sure to do the ninth one.
Fifth you have done? Got the answer?
Yes, sir.
What is your answer? Can you tell me?
So the maximum is x is equal to 4 and minimum x is equal to -2.
Maximum is not that. Maximum value is that. Well, what is that? X value you are talking about or fx value you are talking about?
X is equal to 4.
So that is not maximum, that point of absolute maxima. Are you saying this, that this is a point of absolute maximum?
So 8 is the maximum.
So what will be the maximum?
8.
Oh, it would be 16 minus 8. Yeah, it will be 8, correct. My absolute maximum value. So if you differentiate it, you get 4 and you get minus x equated to 0. So x is equal to 4 you will get. And this is the only critical point C1. End points are -2 and 9/2. -2 and 9/2. Okay, what are you getting minimum as?
So minimum is -10.
-10 is the minimum. At what point?
-2.
-2. Okay, so that would be uh -8 and -2 -10. Okay. So if we talk about 9/2, at 9/2, what is the value? 9/2, it is 9 to 18 minus 9981/8. So this will be 8864 6 and 44 minus 81/8. So this will be 363/8. So this will be equal to little less than it, 7 point something, right? So yeah, the absolute maximum value is still at 4. It is slightly less than it. 8 is 64, it is 63. So have you done this way? Hello?
Yeah.
You took the value at -2, you took the value at 4, you took the value at B 9/2 and compared all the three values and you took the maximum this and minimum this. This is not the maximum or minimum. Fine. Now you're talking about 11th. 11th you have done?
Yes.
So 11th, how you have done? Can you tell me?
So I got A is equal to 120.
A is equal to 120.
Yes.
Okay, how you approach this?
First, I did differentiated and
What
then I
you got
equated
on
it to 0.
differentiating? First, what you got on differentiating?
4x cubed minus 124x plus A.
Okay, now next, what have you done?
I equated it to 0. Is
Fine.
equal to 0.
Okay.
And then since it's maximum at 1, x is equal to like f1, and
Yeah.
then where x is.
So you substituted x as 1. Fine. Perfect. Ninth question is, what is the maximum value of the function sin x plus cos x? So fx is equal to sin x plus cos x. This is the function. So for maximum or minimum, we need to differentiate it. So it will become cos x minus sin x on differentiation and equate it to 0. So when you equate it to 0, you will get cos x is equal to sin x. So it will be tan x is equal to 1. Now tan x, sin x by cos x is tan x, no? Getting it? When can be tan x is equal to 1? Tan x can be 1 at x is equal to 45 degree, that is pi by 4. Then not in second quadrant, then in third quadrant, that is 5 pi by 4, 225 degree. In first and third quadrant, tan is positive. So 45 degree and 180 plus 45 degree. So in one interval, 0, 2 pi whole rotation, these 2 points are there. And we also take the interval 0 and 2 pi. These are the endpoints. Because one full rotation will give you the answer. You don't have to do multiple rotations. So you have 4 points, 0, pi by 4, 5 pi by 4, and 2 pi. And here they are included. It is closed interval. Pi by 4 and 5 pi by 4 are critical points. So when you will find f of 0, that will be equal to sine 0 plus cos 0. That will be 0 plus 1. That will be 1. If you find f of pi by 4, then sine pi by 4 plus cos pi by 4 will be equal to 1 by root 2 plus 1 by root 2. So that will be 2 by root 2, that is root 2. When you take f of 5 pi by 4, then what will happen? You will get sine of 5 pi by 4 plus cos of 5 pi by 4. Now sine in the third quadrant is negative, cos in the third quadrant is also negative. So both will be minus 1 by root 2. So this will be minus 2 by root 2, which is minus root 2. And at the end point 2 pi, in fact 2 pi will give you the same value as 0 because one full rotation is done. Still we have written, so let's write it. This will be 0 plus 1, 0, 1 again. So the absolute maxima is root 2 and absolute minima, if they ask, is minus root 2. Is it okay?
Yes, sir.
You can write it on here if you want to. Have you written?
Yes, sir.
Okay. Now we come to some geometrical problems which are very important in terms of board exams. Like we have one question here. Question number. Let us talk about question number 23 first. So one question I will tell you, then I will ask you to do one question on your own. Question number 23 says, prove that the volume of the largest cone that can be inscribed in a sphere of radius r is 8 by 27 of the volume of the sphere. So prove that the volume of the largest cone that can be inscribed in a sphere of radius r is 8 by 25, 8 by 27 of the volume of this sphere. So we have a sphere which is having a fixed radius r, and there is a cone which is inscribed in this sphere. This is the center of the sphere. Now you have to find largest volume of the largest cone. So this largest means maximum. This is a question of maximum, minimum. You can make many cones since this, and make a cone like this also. You can make a cone like this also. So the cone which they want to ask is the cone which is having the maximum volume. So you have to find that cone. So we took a cone like this, and then we decide when it will give you the maximum volume. So this is a perpendicular passing through the center to the base of the cone. This is this. This is this. This capital R is the radius of the sphere, which is here also. This is the x, which is the distance from the center to the base of the cone. And this portion will be, by Pythagoras theorem, root over r square minus square. Am I right here?
Yes.
Is it clear now?
Yes.
So x is the variable. Now what is the volume of the cone? Volume of cone is 1 by 3 pi r square h. Pi r square h. So what is r? R is this, root over r square minus x square. This is the radius of the base of the cone. So r square will be r square minus x square. Capital R is given. That is the radius of the sphere. Small r is the radius of the base of the cone. H is the height, which is r plus x. Now this is a function of x. When it will be maximum? When f dash x is equal to 0. So we take f dash x, which is pi by 3, to the product rule, r square minus x square into 1 plus r plus x into minus 2x. Product rule we have applied. So pi by 3, r square minus x square minus 2rx minus 2x square. So this will become pi by 3 r square minus 3x square minus 2rx. Now this is equal to 0 for maximum or minimum. So pi by 3 will become 0 there. Let us change the signs here. 3x square plus 2rx. We take minus common also. Minus r square equal to 0. Can we write it like this?
Yes.
Now do the middle term splitting. So 3x square plus 3rx minus rx minus r square is equal to 0. So you get 3x into x plus r minus r into x plus r is equal to 0. So 3x minus r into x plus r is equal to 0. So x is equal to r by 3 and minus r. Obviously, x is equal to minus r is not possible, because in that case, cone cannot be possible. It will be volume 0. So neglect this. X is equal to r by 3 you take. And if you want, you can test whether it is a maxima or minima. But since they are asking maxima and this is the only value which is you are getting, so this is will be the maximum. So you can directly say that this is the point of maxima. So the volume was pi by 3 r square minus x square, which is r square by 9, into r plus x, r plus r by 3, as we took there, pi by 3 into r square into 8 by 9 into 4r by 3. So this will be 4 by 3 pi r cube. We take it like this. This 4 we take, r cube we take, this we take into 8 by 27 outside. So 8 by 27 into volume of the sphere. This is 4 by 3 pi r cube. So this is what we have to show, that the volume of the cone, maximum volume cone, is equal to 8 by 26 of the volume of the sphere. You can write this down from here. Starts from here. Question is given in the book. So starts from here.
Done. No, done.
Done?
Yeah.
Okay. So one question on this type of geometrical figure you can do. Let us do question number 25. Just try question number 25.
So I'm not sure to do it.
I will initiate it. Show that the semi-vertical angle of the cone of the maximum volume of given slant height is tan inverse root 2. So this is the cone. Its slant height is given. It is fixed. That means you can make a cone like this also, but the slant height will be L only. Or you can make a cone like this also, but the slant height is fixed. You can change the radius of the base. Now, the volume of the cone should be maximum. So volume of the cone is 1 by 3 pi r square h. So let us take any one. Let us take this one. This is r. This is h. L is constant. It is given. R and h are variable. For this cone, h will be different. R will be different. For this one, h will be different. R will be different. But L is same. Now, semi-vertical angle, let us suppose is theta. Now, for maximum volume, that theta comes out to be tan inverse root 2. That is what we have to prove. Are you understanding this question?
Yes, sir.
This is what we have to prove. So, here two variables are small r and small h. So, you can reduce them in one variable. For example, you can say sine theta is equal to r by L and cos theta is equal to h by L. So, r will be L sine theta and h will be L cos theta. So, this will be 1 by 3 pi. R square will be L square sine square theta and h will be L cos theta. So, this will be L cube into pi by 3 into sine square theta into cos theta. Now, this volume of the cone basically is maximum and the variable here is theta. L is a constant. It is given fixed length, slant height. So, theta is the variable. So, if you want to make this volume to be maximum, you will differentiate volume with respect to theta and equate it to 0. So, can you do that for this? This is the volume.
Yes, sir.
Right. Pi L cube by 3 is a constant. It will become 0 on going on the right hand side. You have to just differentiate sine square theta into cos theta by product rule and find theta for which this is 0.
So after differentiating, I got pi L cube by 3 sine theta and then root 2
Are you getting?
uh, pi L cube by 3
Can you say a little louder?
or pi L cube by 3 sine theta and then in brackets root 2 cos theta plus sine theta close bracket and root 2 cos theta minus sine theta.
Okay. So it will become 2 sine theta into cos theta. So cos square theta plus cos theta into 2 sine theta cos theta. No, sine square theta into minus sine theta minus sine cube theta. It will become. So it will become sine theta common. 2 cos square theta minus sine square theta. Yeah, you're getting correct. To root 2 cos theta plus sine theta, root 2 cos theta minus. Equate it to 0. So what you will get? Sine theta 0. Another one you will get this as 0. When you will equate this as 0, that is root 2 cos theta plus sine theta as 0. You will get sine theta is equal to minus root 2 cos theta, which means tan theta is equal to minus root 2. And if you take third one as 0, root 2 cos theta minus sine theta is equal to 0. So there we will get sine theta is equal to root 2 cos theta. So tan theta is equal to is equal to plus root 2. So one solution is sine theta 0, another is tan theta is equal to minus root 2, another is tan theta is equal to root 2 from these three. This, and this. Sine theta cannot be 0 because that means theta is equal to 0, and that means the cone is not possible. If the semi-vertical angle is 0, then this is a straight line. So we can't take this. Again, angle minus root 2 taking does not make any sense. So tan theta is equal to root 2 is the answer, which means that theta is equal to tan inverse root 2. If you write tan theta is equal to root 2, that means theta is equal to tan inverse root 2. So this is your answer. And this is what we had to prove. If you see above, theta is equal to tan inverse root 2 for maximum volume. Is it okay?
So I don't know.
We have taken these three factors. No? One factor, this one factor, this one, and factor, this one. Equated them to 0. Sine theta 0, this one 0, this one 0. When you take sine theta 0, you get theta is equal to 0. So that means that this cone is having vertical angle 0, semi-vertical angle. This will be a straight line. So cone is not possible in this case. Is it okay?
Yes, sir.
Another two cases, when you will solve, so you will get tan theta minus root 2 and tan theta root 2. Now negative angle does not make any sense. So tan theta is equal to root 2 is the answer, which means theta is equal to tan inverse root 2. That is what we had to prove.
Yes. Okay, sir.
Okay. So next class, what we have to start? Integration, na?
Yes, sir.
Okay. So let's start integration in the next class. Might be you have next class tomorrow, na? And as
Yes.
they were saying that it will be a long class tomorrow.
Yes, sir. So plan for 3 hours.